Hello Year 12, I'm going to talk to you now about glycolysis. Glycolysis is the first stage of both aerobic and anaerobic respiration, and it takes place in the cytoplasm. You all start with a glucose molecule. That glucose molecule is going to gain an inorganic phosphate. Where does that inorganic phosphate come from? Well, it comes from a molecule of ATP. So the phosphate will be transferred from a molecule of ATP to the molecule of glucose. We call that substrate level phosphorylation. And as a direct result of substrate level phosphorylation, we now have a glucose phosphate. That glucose phosphate will then get turned into a fructose phosphate, and substrate level phosphorylation will take place again. Now, as a result of the second substrate level phosphorylation taking place, we've converted into a molecule called hexose bisphosphate. Hexose because it's a 6-carbon structure, and bisphosphate because it contains 2 phosphates. That hexose biphosphate is very unstable, so quickly gets broken down into 2 molecules of triose phosphate. Now we're just going to focus on one of these triose phosphates, but remember it's going to be happening twice. So the triose phosphate is now going to lose a hydrogen and a phosphate, and that is thanks to an enzyme. It's an enzyme that's going to be removing those. So we all know that a hydrogen is made up of 2 H atoms, we can see there, and our phosphate is now being removed, so it is called an inorganic phosphate. The inorganic phosphate is going to be picked up by a molecule of ADP, and our hydrogen is going to be picked up by a coenzyme called NAD. Now you all know from photosynthesis, when a coenzyme picks up a hydrogen, it becomes reduced. So we just call it from now on reduced NAD. That intermediate molecule will then get turned into pyruvate. And the way it gets turned into pyruvate is again through substrate level phosphorylation. But this time, our pyruvate, our intermediate molecule, is going to lose a second inorganic phosphate, so substrate level phosphorylation taking place again, and our ADP molecule picks it up, it gets converted into ATP, and then we have a 3-carbon structure called pyruvate. So let's just recap, nice and simple. We start off with glucose, which is a 6-carbon structure. It's going to undergo substrate level phosphorylation, and it's going to get converted into glucose phosphate because it's picked up an extra phosphate. You'll notice that it hasn't gained or hasn't lost a carbon, so it's still a 6-carbon structure. That glucose phosphate will then get turned into fructose phosphate, and then substrate level phosphorylation will take place a second time, converting that fructose phosphate into hexose bisphosphate. Again, it's a 6-carbon structure, hence the hexose, and bisphosphate because it contains 2 extra phosphates that have been given to it as a result of substrate level phosphorylation taking place twice, once here, second time then there. Hexose biphosphate is very unstable, so it will quickly be broken down into 2 molecules of triose phosphate. So therefore, each molecule of triose phosphate contains 3 carbons. 3 times 2 gives you 6. It's important to make sure that we don't gain or lose any carbons at this stage. Each triose phosphate is going to undergo substrate level phosphorylation twice, and is also going to lose a hydrogen, and that hydrogen will be picked up by a coenzyme called NAD, therefore becoming reduced NAD. And when that happens to, those 3 things happen to a triose phosphate, it gets converted into a molecule of pyruvate. So there's our pyruvate. It's a 3-carbon structure. We haven't lost or gained any carbon. There's obviously, this is happening twice, so we have 2 molecules of pyruvate. So in glycolysis, we start off with glucose, and we end up with 2 molecules of pyruvate, and we end up with 2 reduced NADs, and we also end up with a net gain of 2 ATPs. And I'll explain what I mean by that is, up here you can see that we've put in 2 molecules of ATP to convert glucose into hexose biphosphate. But then down here, when we convert triphosphate to pyruvate, we actually are creating 4 molecules of ATP. So 2 molecules of ATP go in, 4 molecules come out. So that is a net gain of 2 molecules of ATP.